there's one other flag that we'd like to add, and that's the not exact flag that you see here. Now when we multiply the two numbers together we get a third number. If the third number, when we truncate it, the least significant bits actually have some values in them. So it means that the least significant of the 48 bits of our original multiplication, if there are any values in that, it means those values are lost whenever we truncate it to fit into a 32-bit floating point number. So that means that the value that we've got is not an exact value, it's just an approximation. So we're wanting to know when that is the case. So for example, we've seen before that 0.1 is not an exact value, it's a never-ending 001100110011. So we want to know when that is the case. So that's what we're going to do in this video. So let's head down and I'll show you how I've done this. Now you can see here that in this sticky bit here we've got this little extra pin and it's NE, so that NE stands for not exact. So we know that we're going to get the not exact from the least significant bits of the multiplication, because we know we're going to truncate and get rid of these. So let's head in and we'll see where we can get that value. So we head into the sticky bit. Now the sticky bit contains the 23 bits of the least significant bit. So that's the 23 bits we're looking for. And remember, whenever we worked out the sticky bit, we only looked at 22 of those bits. 22 of those bits. So up to this point here, because the next bit up was called the gap bit, and we were ORing all of these 22 bits here. But what we can do is we can just take the other bit, which is the 23rd bit here, and we can OR that as well, and we can take that out as the not exact, because if any one of these 23 bits go high, we know that there is a value in one of those 23 bits, and we know when we truncate we're going to lose that value, so we're going to lose some information, or we're getting an inexact result. So this is our method of finding the inexact flag. So another thing we'll have to do with this flag is I'll take the inexact flag, so I'll call it NE for not exact. So we take that NE and we put it into the special cases. So this is it going through the special cases, and that's the NE input here, and then the NE comes up and it goes into the multiplex. So if I head into the multiplex, you can see here that what we want to do is we want to ensure, I'll zoom out a little bit, see it, so that the actual extra sections in here, it's hard to see this level, but that's the extra section I've added. Now, and this is the not exact output. Now we only want the not exact flag to come on whenever we've multiplied just a normal number with a normal number. We don't want the non-exact flag to come on whenever any of the special cases, or the special values come on. So for example, we get a plus or minus infinity, or plus or minus 0. We don't want the non-exact flag to come up for that. So we have to ensure that we add this extra AND gate here, so that if any of these go high, then this will go low and it won't pass the non-exact value out. So that ensures that it won't get an output for any of these. But we don't want a non-exact output whenever any of these values here go high either. So these values here, remember, are the values that we get whenever we multiply together just normal and subnormal numbers, but we get overflows to plus and minus infinity or plus and minus 0. We don't want the non-exact to appear in that instance either. So again, we can just NOR these together, and then we can AND them at this point here, and that will ensure we don't get a non-exact coming through whenever any of these go high. So we want the non-exact to come through, but not whenever these go high or when any of these go high. So that we take this non-exact output here, and I'll show you where it goes here, just so you can follow the route. So the non-exact here, that's the input for non-exact, and the output comes out here, and that's the non-exact output. So this is the final output that goes to the top level. And this is the top level here, and I've just called the top level out the non-exact output, and this is the pin for the non-exact here. So that's going to give us a value for our non-exact. So that's all there is for this video. I'll get you in the next video. Goodbye.